Hello and welcome to the Nights of the Neurocareers Roundtable June 25 edition. And today we have more than 140 people signed up for our event. So our event is gaining popularity. I'm so happy to see that. And the main purpose of this event, this monthly event, is to build a welcoming and informal space where we can exchange insights on neurotechnologies, career opportunities in neurotechnologies, entrepreneurial journeys, and visions of the future, like today, from NeuralOS systems to vestibular training, even science fiction storytelling. I hope that our main person will join as well this event, who will be able to talk about that and also emerging BCI research. And so I would like you to welcome our today roundtable panelists. So I am a facilitator of the event. My name is Milena Korostenskaja, simply Dr. K, or just Milena. And I'm a Neurocareers coach, founder of the Institute of Neuro Approaches, and the host of Neurocareers, doing the impossible podcast. And with me today are Courtnie Paschall, Dr. Courtnie Paschall, who is a founder and CEO in Virtualis, an SF-backed neurotech startup. And she will tell more about herself. Also, we have Nikhil Verma, who is a neural engineer, a neural engineering doctoral student from Carnegie Mellon, and he is also MIT Media Lab affiliate. We will have Sheila Thelen, and Sheila is a founder of Vestibular Training Technologies and international speaker. And I hope that also Dante Terese will join us. She is a sci-fi author. She is not here yet, but let's hope that she will join us as well. And she is the base book series author, which is now being adapted for a film. Yes, for a movie. So one more thing I want to mention before we get into the all the information and talks and discussions from our panelists is that this is a live event, which means that you can send us live questions, yes, and we will answer them as we receive them. So it's a great opportunity for all of us to communicate, to discuss, to express our opinions, concerns, and maybe even find solutions, yes, to certain challenges that are that arise in this field of neuroscience and neurotechnologies. And we will have just approximate plan of our event. There will be introduction from our panelists, and then they will pinpoint current trends in their respective area of neurotech. Then they will also talk about their absolutely amazing current projects, and we will discuss challenges in their fields and how to solve them. And also, we will try to share opportunities in neurotech as we see them, maybe some seminars, conferences, maybe even job openings. So we will see what our panelists have in place for us. So let's do it. And now our amazing panel, thank you so much for coming and for doing this. Who would like to introduce yourself first?
I'm seeing finger pointing.
Okay, I see it. Sheila is pointing.
Well, you're pointing to
Courtnie Paschall.
My pleasure. So Milena, thank you for the invitation and the opportunity to be a part of this panel. I loved what you've done with Neurocareers podcast. I was early in my kind of journey as a graduate student. I had the opportunity to speak with you first. And it's been wonderful to get to be on these panels since then. So a bit about me. I am a founder, as you mentioned, of Virtualis, a company leveraging, we'll say, multimodal AI to build better interfaces between implanted neural devices and an increasingly digital world. This company came out of the work that I did as a graduate student, where I built the first bi-directional virtual reality implanted brain-computer interface, connecting a user's intention to a virtual action, and then being able to stimulate the brain directly in response to deliver a neurohaptic sensation. So closing that loop. I realized in the process of that that there were potentially more efficient ways, we'll say, of using neural signals to build that connection between the human and, in this case, a virtual world. I've now pivoted to more augmented reality and working in that medium now. My team is great. I love the startup side of things. I know we'll have an opportunity to chat about it. It is a fascinating vehicle for, we'll say, cutting edge engineering and science that I didn't realize as a graduate student was kind of I guess, another way of continuing that innovation journey. It's been great. I'll pause there.
Yes, thank you so much for your introduction. Courtnie, any questions for Courtnie right now? Maybe even from our panel. Nikhil, I know that you were looking forward to being on the same panel with Courtnie, and I know that you're familiar with your work. Anything you would like to ask?
I was just curious about the latest work that you have been working on, but I'm sure that you'll be talking about it eventually.
Yeah.
Well, I happily come back around. Yeah, agreed. It's a fun world, and what we're doing is so in the midst of this incredible wave of accessible AI, extended reality, XR technologies. This is definitely a really sometimes overwhelming, but most of the times deeply inspiring time to be a builder.
Yes, and I'm very curious, Courtnie. You did your research, clinical research, but it still was academic type of research. And now you are building your own startup. Yes, like seriously building. What is the difference between those two things? And maybe what things are actually the same that you can already bring from what you acquired during your academic research, what you can bring into your startup development, and what things you still need to learn, which are different from that previous environment.
Mm, a lot packed into that question. I will say things that are similar between, we'll say, an academic research environment and a startup are, it actually in many ways the pacing. So as a master's student, graduate student, and then I'm guessing as a postdoc, there's a certain kind of rush tenor to everything that you're doing. That kind of underlying anxiety that you could always be doing more. That doesn't change in startup land. I don't know if it changes if if you move in a different direction. No, everybody shakes their head. Then I think it's possible that the personality that you know bothers to go into academic research is already naturally inclined to that entrepreneurial journey. The thing that's different, I would say, are the kind of the requirements and maybe the well, I'll say, yeah, the demands of what your product does. In the research setting, what you're building must further the scientific body of knowledge. Your obligation as a scientist is to produce something that you disseminate so that other people can now take that information, that technique, that method, and make their own next steps, etc., down the road. On the startup side, you have a financial obligation to the company. The company that you founded must survive, and the way it survives is if your product can make money. And so the thing that you're building must meet the needs of other people or other businesses in a way that justifies them giving you their lifeblood, right? Their financial stream. And those are different contributions to different, but always larger communities. And then I think all
Yeah.
the similarities and differences. Yeah.
Yes, thank you so much. And why I'm asking, because the trend that I see currently, that of course more and more students want to join industry, but
Mm.
actually there are even more students that were young uh, career people in careers in neurotechnologies who want to build their own startup, who want to build their own device. So that's why I think this topic is so important. And that's why I asked you. So thank you so much. Thank you so much. Courtney, and who would like to introduce themselves next? Okay, Nikhil. Okay, let's
Hello,
do it.
everyone. I'm Nikhil Verma. I'm a graduate student in mechanical engineering at Carnegie Mellon University, and currently my research has been focusing in the field wholly in neurotechnology, neural engineering, but specifically the research has been focusing on sensing and modulation of neural circuits for two major applications. One of them is restoring function after any sort of neurological condition. That could be paralysis, is currently what my focus is. And the other application is for human computer interaction, to have more inclusive human computer interactions in people with these motor impairments. And yeah, more specifically, I've been working more recently on using spinal cord stimulation, also electrical stimulation of the spinal cord, to restore movement in people with stroke in the arm and hand. And I've used both implantable and non-invasive technologies to be able to do that. And on the other side, on the sensing side, we have been able to record activity from the paralyzed muscles using electromyography in these population with severe motor paralysis who doesn't have the ability to be able to control their entire arm and limbs.
Very, very impressive. And what are your plans after you graduate? Of course, if you want to disclose them, you don't need to, but
Yeah,
what are
so
you
I'm
thinking?
currently in my last year of PhD. So the plan is, as you mentioned, there's a lot of folks like me who is trying to get into the industry. So the plan is with all of the experience that I've built, both on the sensing and neuromodulation, to be able to bring these systems that we have been developing in research to and have these more accessible to these patient populations. So then my plan is to go to an industry and make these systems more accessible to patients.
Yeah, thank you so much for your introduction. Any questions from Sheila, from Courtney?
Wow. It's always fascinating to meet people doing such amazing work. Congratulations. What an honor to.
Thank you.
Yes, and I think that our viewers here are also very impressed. We have Ramona von Lieden, a PhD, who said that what a powerhouse panel. So she's happy to see our panel. We have Faisal Qureshi, also sending hello from Great Britain, as I can see. Okay, and we have actually Violeta Tulciano, and Violeta is doing absolutely amazing work in neurotechnologies in the neurosecurity space. So she wants to make sure that our neuro devices, when they're implanted, they cannot be hacked. And also she's considering, can we use our brain for actually signing documents, signing important papers? And I think that's such an amazing area. She does her research at the University of Leuven in Belgium, and we recorded a wonderful podcast. So if anybody wants to listen, I highly recommend. So thank you very much for joining, Violeta. I hope to see you on our panel next time. So we have, and also Ramona says that yes, this is a great group of neuro nerds. Thank you, Ramona. I hope you will join us also next time as a panelist. But please send your questions. Yes. Okay, very good. And we have Sheila Thelen. Sheila, welcome. And can you tell about yourself? What do you do? Yes.
Hi, I'm Sheila Thelen, and Wow, what an honor to be here. So I'm not as exciting, but what I am is doing. I talk about trench warfare of work in the neuro world. We designed a product called Vestibular Training Services, and we come actually from the sports world. So we're bringing world class sports to the general public, and we work with about 2 million kids have grown up on our gear, especially in the world of figure skating over the last 30 years. So we've got just decades and decades of athletes that have grown up on our gear worldwide. And 5 years ago, we expanded into the general public, which was really fun. In January of 2020, we're like, this is going to be great. What could possibly go wrong? And then, of course, COVID and all those good stories came up. So we launched our company at the beginning of COVID, which was super, super fun. Highly don't recommend that. But it's been an adventure in this process. So we've teamed up all over the world, and our gear is worldwide, and really applying vestibular training in a spinning motion to the entire planet, but to all people with a brain. So our projects have been extraordinary in the fact that it's been everything from children with autism, young children, a lot of balance issues, ADHD kids, concussions, world champions, Olympians, Parkinson's, Alzheimer's, dementia, aging population, fall prevention, COVID, fuzzy COVID. Like we've just really worked with everyone with a brain, and really with the goals of the four biggest things of vestibular being improving balance, cognitive, spatial, and sleep. So somewhere in there, we're doing projects with the military, which have been this incredible adventure that we've gone on in our company. So yeah, we just kind of keep growing and growing and working with more and more people. But what's been really fun about our projects is we've really teamed up with different specialty people around the world. And we always talk about manufacturing here in the States and getting our gear into the hands of one specialist, but that one specialist could help 1,000 people. And I'm even just seeing Paul here talking about veterans. Yes, we've done a lot of work with veterans with outstanding results that we are truly honored in some major populations to get to work with. So it's really a daily adventure of who in these projects are going to be. One of our big vendors, one of our big clients down in Tampa, are oxygen specialists. So to see our gear tied in with oxygen. One of our big master trainers in Colorado Springs really works that veteran population. Really exciting work in that group, both active and veterans. One of my big favorite people, Tanya Yardley up in Vancouver, Canada, her work with concussions and underserved populations, specifically Indigenous, like First Nations, is really, wow, like our company, even on a daily basis, we'll get messages in. I'll be like, you're doing what with it? Wow. So our company keeps growing and doing really innovation in a very non-invasive way. And almost it's so basic, it's elementary, and what that's doing with the brain. So we're excited to be here, and holy doctoral groups. Thank you. Wow. I don't have a doctorate, but I also talk about I've worked with so many athletes. We tried to figure out the number at one point, and I think I'm a little over 500,000. And that's a lot of kids, man. That's a lot of athletes. That's a lot of kids. But how can that apply to Mrs. Anderson and to a child with autism? So these are the projects. So thanks for having me.
Yeah, thank you so much, Sheila. Beautiful story. I know you are doing amazing work, and we will see actually what it is today. We will have a video from Sheila. Now, let's, and also we already have somebody interested in veterans. Yes, Paul A. So supported Sheila with what she was talking, and Ramona von Lieden, she already agreed to be our panelist next time. So thank you so much, Ramona. Very good. So now Let's just talk. Any questions for Sheila, actually? Any questions from Nikhil, Courtney, or anybody from our viewers? Mhm. Not yet? You will? Okay, Stephen Applebaum. Thank you so much, Stephen, for actually being again here with us. We will need to get you on our panel next time. Okay.
Sheila, I
Uh,
have a question.
okay.
So you mentioned a very wide variety of target population with this vestibular training. Um, how do you think it works, or what is actually going on that might be causing all of these effects that you just described?
To be honest, this is the exciting part of the whole project is, and I love my little, I love a visual aid, the good old vestibular system, like inside your ears. And we really, inside the vestibular system is a gooey gel, so it's a really, really gooey gel. And it's the base for sure of all of your balance. So when we talk about like vertigo, there's a pooling of the gel and the other sides go dry. And now you're crawling for the bathroom for days, weeks, months. It's terrifying. But really, in that centrifugal motion and that spinning motion, we're moving that gel evenly through the vestibular system. So there is that immediate improvement in balance. But then, in the same sense, too, with some centrifugal force, trying to get some of those crystals out of the main canal that have fallen in, especially people that ride in Humvees or have concussions or joggers, horses, like that. Those crystals really can drop out and into the canals, and it's really this weird problem that no one can really describe. They're like, yeah, I just don't feel good. I just can't process very well. I'm tired all the time. I don't sleep well. And really, it's those crystals that are interfering. That if we can get those out of the way, it's such an easy move with centrifugal force that we can get a lot accomplished immediately. So the first time you work with me, people assume it's like a vertigo. Like, oh, I'll be dizzy, I'll be barfy, like I'll be super nauseous if I do that. And that's our number one comment is people are like, especially when you see my really, really fast videos that NASA used. NASA was like, how'd you do that? Because the girl at the end says she's not dizzy. Even though we spun her like crazy, she's not dizzy because it's trainable. You can train that vestibular system. And
And
so
Sheila, maybe you can show actually the video, then everyone will understand actually what are you doing, what's happening with the person. Yes?
it's shocking. Like I love, and actually you're gonna laugh. It's the video I send out to everyone because people are like, "Are you kidding me?" But it was really fun when I first posted it, and NASA was like, "How'd you do that?" So this is my most famous video. It's one of my athletes who went from an average athlete to like a Team USA kid, and then from there she also went from a good student to suddenly a world class, like graduated early student. Um, so I'll just throw it just up here like this. So it's a spinning platform, and we just crank her up. And not only is it vestibular, but it's axis, balance, proprioception, midline cross, chaos training. So that's where my military and my elite shooters and my cops and firefighters all love this gear in that sense. But the cool part is, of course, she's not dizzy. Oh no. Oh no, what happened? Oh no. Oh no, the video went. Oh no, no, wait. That was a
Okay, she's
oh
gonna do
no.
100 on the speed spinner. Here we go. One,
Oh
two.
no. Here we go.
This is we got David.
Hold on. Oh, here we go.
How dizzy are you? I'm not dizzy. Not that dizzy. Not dizzy at all. Thanks. Have a great day.
And NASA was like, how'd you do that? And the answer is it's trainable. But then, of course, my other videos are so slow with people barely turning. And when you talked about stroke patients, I've had several stroke patients that literally do one turn. And they need to rest and then one more final turn the other direction and they're done. But that's really where they start. So as we deal with different injuries and concussions and starting slow and then eventually being able to go longer, faster, adding in more things, more eye training, more vestibular work, more head movement. Um, our new thing is actually tracking time in chaos, which we call time warp. that really the fire departments brought to us of athletes and firemen that would go in and fight a fire, be in for 4 minutes, but in reality it was an hour. And the team would die because they really couldn't track time correctly. And the same thing, my military guys, my elite shooters talk about being settled in for 2 hours. They check their watch, it's been 4 minutes because time isn't moving correctly. So we've been working a lot on time warp and trying to control time in extreme chaos. So like our projects just keep expanding. And I joke, we love us a weird project. Like if you said like, okay, here's the problem, concussions, I'm like, okay, well, let's tackle it in this way. So we really do a lot of really different projects in all different populations. So really going back to the question of moving gel and crystals out of the way, yet at the same time, in improving that balance instantly, we can really crank down on the anxiety, especially on older adults, much less ADHD kids that aren't moving enough.
Very interesting.
Amazing. Thank you so much.
Yeah, thank you, Sheila. Okay, so now we already have actually several future panelists already from our viewers. Thank you, Stephen. Thank you, Dr. Lydon. And my next question is, maybe we can talk about what's going on in your respective field. Yes, what are the newest updates? I know Courtnie visited several events, conferences. Where are you talking to us, Courtnie? Is it from Japan or you already in the States? Because I know you were traveling, so maybe you can start. Yes.
Happy to. So back in the States, easy time zone to jump on this event, which was good. I would say so. The event in Japan this year was the Computer Human Interaction Conference. Big conference, really wide umbrella. It was my first time at CHI, and I didn't exactly know what to expect. But then I've had team members at robotics conferences and ICLR, which is a large MLAI conference that was in Singapore this year. So I've been able to pull in from a lot of information. I would say general themes and trends. We'll say the academic world through, I think, 2023 and the first middle part of 2024, which would have been what was represented mostly at these conferences in terms of submitted papers. Very much the application of large language models in human user interfaces for CHI, working on extending multimodal integration, we'll say technologies in robotics, and then in the MLAI space, moving very quickly, but where we kind of focused were the groups which are kind of building the human in the loop side of these things. So of course I'm biased coming from a neurotechnology space. I want to harness these kind of ways of processing data real time for the benefit of human users. So we focus there. I would say themes, the XR world, so augmented reality, the idea of running around mediating your experience with a headset has been kind of on people's lips for a decade, and it's really struggled to find its use case. I think we're seeing with kind of this AI proliferation, we're seeing a lot of people being able to move very quickly on kind of doing something with these interesting sensor platforms that we got used to the idea of walking around with on our heads. So I would say big themes we're seeing, right? Synchron made a very recent announcement of a BCI human interface kind of design standard. Interesting in a kind of a related field, there's now an input standard for haptics. It doesn't yet include neurohaptics. It probably should. But we're seeing these design standards start to spread out across these futuristic human interface devices. I think that will continue. BCI will jump on that wave as it should. Neurotechnology will incorporate these further. Synchron's doing a great job. And then I would say other themes and things that I'm seeing on the neurotechnology side of the house. is getting kind of simple solutions, even classic decoders, out of the lab. And I'm seeing labs get to focus more and more on this refined adaptive space. I haven't seen those make a commercial transition yet, but the possibility of a commercial transition in neurotech is so new that kind of makes sense. So that would be my read and my take and my little niche world.
Yes, yes, that's beautiful. And what I wanted to ask, do you see any trends in terms of career development? Yes, because you even already mentioned that even labs, yes, in research labs, they're trying to make, as I understood, some attempts towards more commercially available product, at least the attempt, yes, to finalize something into something that can be used, yes, further. So there is this trend into more going into industry. What did you notice communicating with people, being at the conferences, where the careers are going, and maybe what spaces are opening for the careers in the field?
So I would say this connects very much to the question you asked, or that you've noticed that there's a lot of, we'll say, young academics that are eager to get their degree, whether that's bachelor's, master's, PhD, and then go do their own thing, go build their own thing in industry. I'm hoping that the market continues to support that. I think it's likely that academic spin-offs in neurotechnology have a commercial hardware base that they get to interact with or build for that didn't really exist before. There were commercial companies providing resources to academic institutions, right? So revolving door, but there wasn't really a consumer outcome. And there is becoming reasonably a consumer neurotechnology outcome space. So I think I'm hoping that pathway continues to open up and there are increasingly industry-based jobs, room for startups, room for interesting ideas. And then I think again, the one of the things that the one of my takes on what the internet did is it connected small groups of people that can be very low percentage, but around a global community can be thousands, tens of thousands, hundreds of thousands, millions, right? And those numbers feel big when you put everybody in a room, but it's when it's one person in a town, right? You can feel really isolated. And so I think in an analogous way, one of the things that AI technologies are going to do is give these kind of people with niche problems the opportunity to solve their niche problem in a facilitated way. Multiple tools are helping people do that, and then connect that niche problem to that user base of thousands, tens of thousands, hundreds of thousands, low millions. And that's enough to keep you afloat as a startup. So I guess what I'm saying is I see the world through distributed engineering talent with AI. And then increasingly, I think we'll see micro manufacturing and micro fabrication. I think the I want to start my own startup will become not just very real and very accessible for more and more people, but something that people do serially. You have an idea, you build it, you connect it to your community the way you would jump on a chat forum, and then you move on to the next idea. So I think it's a great thing for academics, young academics in particular, who maybe had imagined that iterative, have an idea, build it, write a paper, move on to the next idea. Well, you might be able to do that increasingly with a company, with a product, with something that has commercial potential.
Where would you recommend people with the idea to start if they have this idea of developing their own startup and creating their own product?
So it's not very helpful for me to say it the way I'm going to, but I'm going to say it anyway. It really is a just start. There's like the, trending, I don't know, we don't hashtag anymore, but whatever, hashtag that's like, you can just do things. You really can just do things. I would say while you're a student, at any level, as long as you're affiliated with a university system, and that might change, but universities are big bureaucracies, so it will change slowly. you are surrounded by an unexpected wealth of talent and resources, and you won't realize it until you're out, out of school, maybe in a job, and your resource pool has shrunk. It might be, higher quality in your specific area, but the incredible breadth that you have access to as a student, um, is phenomenal. I think it might be one of the greatest value props of even going to a university is your ability to connect to experts and have access to high quality tools for any topic discussed at your institution. It's pretty incredible. So any idea you have, just do it. And by what I mean is take that first micro step. Contact the professor, the grad student. Grad students are the best ones to reach out to because we have no time, but we have this really big heart. So sleep deprived will answer all your questions. I think, yeah, that would be my recommendation. If Unless you have a commercial transition, somebody that can fund your startup, don't leave school to do it. And if you have a really good idea and you don't have access to resources, maybe go to school.
Yep. Thank you so much, Courtnie. Yes, Sheila, please.
I totally agree. Oh my gosh, absolutely. And the resource that I really used a lot was LinkedIn. I have to tell you, that's where I met almost all my connections. That's where I met NASA, my NFL people, my MBA people, my chief medical officer, my PhD research coordinator. Like where I met everybody was on LinkedIn. Same thing. People were willing to share their time in a shocking manner. And there were people out there I didn't even know about, much less have access to, that would contact me. Like I really had a lot of help from LinkedIn. So it's such a weird thing. It's not a job search. It's a huge network of people really worldwide. But my client in Mumbai, I met on LinkedIn. Like, how would I ever connect to someone in Mumbai? And she has our gear. So I look at that, and I look at opportunities, and I look at networking, and I look at all the ways that you can really build a company. And you're exactly right. You got to start. Step one, go. Go. You got to go. Um, the trick is not going into debt to get there, and how good is the idea. Um, and that's where your family will tell you you're brilliant, or your family will tell you you're dumb. Okay. And sometimes you can listen to your family and sometimes you can't. Like you got to really dig through the idea. How great is the idea? I always love to tell people too, don't quit your day job. Like run it as a side hustle till it really hustles. Be careful how you expand.
I want to jump in on that one. So Sheila, obviously, evidently, one of the things that you did beautifully is you put your idea out there. Milena, you asked, like, what's something I'm still working on? I have a perfectionist side that wants to keep everything in house until it's good enough to talk about. And I know consciously that's not the right answer. I know that the right answer is if you put your idea out there, you are already starting to make contact with the communities that have been looking for your thing, whatever your thing is, and they'll help you do the work to bridge between maybe what your nascent idea is and what that community needs. But if you don't put it out there, no one can reach out to you from Mumbai to be your next client. So good on you, Sheila. That was a huge benefit in your willingness, and something I'm still working on.
Yes,
And just
yes.
to double down on that, I know we are still speaking about like the building a community. And just because Sheila mentioned LinkedIn, I will say that every single affiliation that I have had so far, MIT, University of Pittsburgh, all the internships, all the PhDs, is literally only because of LinkedIn. So really feel free to reach out to every single person that you can. Like attending all of these panels has been really helpful because, for example, me who has a biomedical engineering background, who didn't have any neuroscience or neural engineering background in my undergrad, this is how I basically learned about the field, reached out to people, learn more, talk more about them, and then ask for opportunities. They might have these funds to be able to bring you here to the US, and that's exactly what happened with me. So yeah, LinkedIn is great.
Yeah, please,
almost feel
please.
like we need to make an announcement that like we don't have to say that being on a LinkedIn live event. It's not like there's like a subtle pay line or something. Three statements.
We have
It seems like LinkedIn should give me like a free membership.
Mhm. We just repped your brand, so
Yeah, LinkedIn, but like, yeah, like there's just so many opportunities, and like once again, like people you didn't even know were out there, and this is where you can kick it around, you can meet new people. It really is where I met my military contacts. And I always have to add into what's the best thing that happened to your company? The military. What's the worst thing that happened to your company? It's the military. So those people just always, I know, remember when I first started, people were like, oh, you should work with pro athletes and you should get in with the military. And I kind of looked at them like, well, yeah, duh. But at the same time, do you know how hard that is? Do you know how hard it is to get a military contract? Do you know how hard it is to work with pro athletes? You just can't knock on the door or call in and be like, hey, can I work with all your pros? No, like it's really, it's a process. And I personally thought it would be easier. Yet at the same time, it was so hard that I liked that too. Like if you also said it'd be super easy to launch a huge business and neuro network, like the fact that it's hard is something that all of us appeals to all of us too. Like if it was really easy, we wouldn't be interested. If you said it'd be almost damn near impossible, you're like, ooh, I'm interested. Let's talk about this. And I think that's what you see on all of these panels are people willing to dig in, work, sleep deprived. I haven't talked to my family in weeks. There's lots of pieces to this that I really get. One of my favorite buddies on LinkedIn talked about locking himself in his mom's shed for weeks, like no food, like wasn't drinking water, like worked without stopping, in a great tunnel vision way. And I have to tell you, I'm seeing some of the comments here, and I'm looking at some of these amazing people in the comments. Like, holy, like there's some crazy leadership at these events, and it's really exciting to see people supporting and growing and really teaming up to get these projects forward. I do think that is the one little piece that I've been really successful at, because I feel like in a lot of industries they fight amongst themselves. I've worked really, really hard over the last 5 years to bring companies together. We've really done almost all of our projects in partnership. And you were talking about bringing things forward, but I'm trying to make the big jump to the general public right off the bat. And I do have one little piece of vague news. We're doing a huge partnership with a monster, huge fitness company to bring training to the general public. So you can work out your body and your brain in the same location. But what we did is we teamed up with NeuroTracker and Dynavision, Zeus, boards, and oh my gosh, balance tracking systems and Maverick and MyGear. And we're also adding in, I'm so excited, NeuroCatch and Tanya Yardley and Biooptimizational Institute. And we're adding in all of these other groups, SmartFit. And we're also Brain Innovations, like all of these groups that can really team up to come forward into an industry rather than fighting amongst themselves. And this is how our whole industry can really move forward. We've even talked about, you're going to laugh, taco trucks, like a taco truck full of neuro gear that's portable, that you can move around. I originally called it a library bus, but people didn't know what that was. But they knew what a taco truck was, so, but a taco truck full of neuro gear that could be portable. We could bring it to Girl Scouts, Boy Scouts, community centers, not having to be brick and mortar. Like all of these projects can move forward quicker and easier
Yeah.
when we team up.
Yes, absolutely. Thank you so much, Sheila, for saying that. And indeed, Sheila is a wonderful communicator, collaborator. She was on my podcast, and I had already 117 podcast in general episodes recorded, and Sheila was just so phenomenal. She sent me a handwritten card. Yes, and the book, also with handwritten thank you. I would never expect anything like that from people whom I interview, but it just warmed my heart. She's just so thoughtful, about everyone she interacts with. She's amazing. Thank you very much, Sheila, and for all your insights. It's beautiful. So we also have here from Paul A. Thank you, Paul, for sending your feedback. Fail fast, adapt, and overcome. And it reminded me about Dr. Wiggins, Amanda Wiggins. I just interviewed. She's from New Zealand, and she also has her startup that she is heading. And she told that in New Zealand the failure rate for first-time startups is 90%. 90% failure rate. That's a lot. But the good news, I asked her, so what happens next? Are those people who failed get a new idea, yes, then adapt and do it again? She says yes. So usually these are very often the same people. They just make conclusions, yes, from their experience, from their failure, adapt and come up with new ideas, and eventually they do well. Yes, which is important to remember. And our latest podcast, it was with Dr. Clark, Dr. Martinez Clark, and he has a company, a medtech company, that does clinical trials right now in South America. And what he said, and I recommend listening everyone who wants to establish their business, but what he says, that you will fail. There is no question, you will fail, but you then learn from it, and you go again, yes, and you do it. So don't be afraid of failure. I think that is very important. So thank you, Paul, for reminding us about that. And we have several more comments. Tanya Charlie, thanks for assembling the all-star team. Thank you very much, Tanya. And she also says collaboration is key. Yes, thanks, Sheila, for being such a great connector. Yes, and Sheila definitely is. Okay, so let's move and listen from Nikhil. Nikhil, what's going on in your area of expertise? What trends do you see in the science of things? Yes, and also maybe you can tell us what's going on in the career area for young professionals, yes, on the early stages of the career development in neurotech.
Yeah, so let me start by just describing, for example, what happens in my lab generally, because I think it's a very good representation of the field. So my advisor, Professor Doug Weber, he is also one of these crazy collaborators who absolutely loves bringing in companies and the lab itself and really make translational neural engineering devices. So we have collaborations with Meta. You all might have heard of the latest device that they were working on, the EMG devices or the neural interfaces devices, at a very large scale. So it's really exciting to see these really big tech companies also getting into the field of neural engineering and making all of these neural interfaces. And yeah, he's also collaborating at the moment with Stentrode or Synchron, as Courtnie mentioned. Again, so by having all of these collaborations, it gives the students the opportunity to be able to work with these systems that are being developed by the companies or startups and bring it to the people and directly apply all of these systems. So I think that is very good representation of the field itself, because in the last 6-7 years of when I have been of course, as a student in the field, I've seen this trend going where there were labs really working by themselves in the university environment, bringing these systems. But then now they are really bringing in to the real world and actually bringing into the patient populations. Also, in my experience so far, the systems that I'm currently describing, for example, the work that we do with the restoration of motor functions, we are using an existing device from Medtronic, which is FDA approved, and so these leads are approved for pain, improving pain for chronic pain purposes. And these have been in the market for years now, but we are repurposing these leads or implantable leads to repurposes to restore movement. So these spinal leads basically have a slightly different location, but it serves the same purpose. So we can repurpose these FDA approved devices for the target that we know, which is in the case for restoration of motor functions. I've been fortunate enough to be able to go to a lot of conferences, really highly focused on neuroscience, at least at the moment, just because that has been my focus for the last few years. But here, I've noticed a lot of these on both the aspects of, again, sensing and neuromodulation itself. But now I see all of these combined, where there are a lot of closed loop systems, where there are a lot of signal processing, real-time signal processing algorithms to be able to sense the signal from any population, make sense of all of these signals using, let's say, decoding algorithms like machine learning, and then use all of those information to be able to make changes or deliver stimulation to be able to affect the current state of these participants. So these closed loop systems doesn't need any human interventions anymore, and they can be really specific. So you can imagine just performing some sort of neuromodulation, which is traditionally done in case of DBS or spinal cord stimulation. Now, by making these closed loop systems, you can get rid of all the off-target effects, because you can now have a temporal aspect of the stimulation itself. So by having these closed loop systems, you can get rid of, really target the specifics in both space and time. So this is the trend that I'm also really seeing, that we also try to use in our own research at the moment.
Yeah, that's amazing. And what do you see in terms of career opportunities, career trends for the early, for people in their early careers stages? Mhm.
So I think I can very effectively speak about the early career, at least in the student stage, because coming from India, which doesn't really have a very developed neurotech or neural engineering programs, I think there's a lot more, like I'm seeing an insane amounts of students coming to these amazing universities like University of Pittsburgh, Carnegie Mellon, who has these really built programs for neural computation, neural engineering, neuroscience, which I think has been really helpful for all, like covering all the basics. So in my undergrad, I've been focusing on like signal processing, electronics, building all the very basics, hardware and software engineering skills that are really important for any neural engineering or neuroscience applications that have been working on. So I feel what I've noticed so far is people have really tried building these very basic skills, including myself, that can now be general applied to a much larger fields, for example, in the fields of neurotechnology. And of course, like collaboration has been something that I've seen very often, where of course, like one student cannot work on both hardware, software, signal processing, building the entire system, running the experiments. So the team, for example, the projects that I've been currently working on have, like the clinical trial that we work with in these patients with paralysis. Every single day, there's at least 3 to 4 PhD students doing all of these experiments, working on all of these systems. And then there's a bunch of PIs. So there's a collaboration between University of Pittsburgh, Carnegie Mellon, and UPMC. So UPMC is basically responsible for all the neurosurgery. Carnegie Mellon is responsible for a lot of engineering, and University of Pittsburgh, it has has an amazing biology background, and that's where most of the resources for doing all of these experimentation exists. So I think collaboration is also one of the things which is really important, and I've seen this in the fields as well.
Yeah, thank you so much, Nikhil. Any questions to Nikhil from Sheila, Courtnie, and our viewers? Please send your questions. Mhm. Yeah, anything? Mm-hmm. Not.
Waiting for viewer response.
Yeah.
Nikhil, I'd love to learn more
Mhm.
about your work with EMG. So it's interesting. I was in implanted devices, so I was kind of very far away from the periphery. Are you seeing more, we'll say, central nervous system recording modulation paired with EMG, and where do you see all that heading?
Yeah, it's a really interesting question because one of the papers that I'm working on was exactly on that. So what we were doing, just speaking, starting with EMG, one of the things that has been shown in the lab of Doug Weber is that even with really severe paralysis after spinal cord injury, there were still some signal bypassing the injury. So if there was an injury, let's say in the cervical spinal cord, there will still be some neurons bypassing these injury and still allowing these signals from the brain to get to the muscles themselves. But these signals are not strong enough to be able to generate movement, let's say, of the individual fingers. But using these really high density EMG, using non-invasive methods, you can still record from these residual muscles at both the muscle level using EMG, but now there's more novel techniques called motor unit decomposition, where you can really localize the activity at a motor neuron level. So then you are actually able to detect and decode these movement attempts made by these participants with really high levels of paralysis. And this same concept is used by Meta as well, where they are using this wristband. And we also have a collaboration with Meta where we are doing exactly that. So we are using their Meta wristband, who's able to record from these myoelectric activity in people with severe paralysis and allowing them to to basically control either a computer cursor or virtual environments. And on the stimulation side, I've explored both these implantable stimulation of spinal stimulation and transcutaneous spinal cord stimulation. So one of the things that we have been doing is we are trying to understand the mechanisms of how spinal cord stimulation is actually restoring these movements. So basically what we see is what are the effects of these spinal cord stimulation on the motor neuron activity themselves on when we are delivering these neuromodulation. And what we have seen is that with the spinal cord stimulation, there is a facilitation of these motor neurons properties or firing. So we are basically increasing the facilitation of these motor neurons, which were able to receive these signals bypassing the injuries. And that's why we think we are seeing these facilitatory effects in restoration of movements.
Yeah, thank you very much, Nikhil. And maybe it's a good time for everyone to share what you're working right now on. Yes, and Nikhil, maybe even what you said will be reflected in your slides, if any, but it will give us more visual information to go with. Um, would you like, as just continuation of what you were just talking, to share a couple of slides and explain?
Yes. So my slides are really focused on the spinal cord stimulation work because I think it was a little bit easier to talk about one specific thing instead of trying to keep it
Yes.
general. So let me share
Mhm.
slides. Let me try to see if the screen
And
share.
meanwhile, I can share, we had a wonderful note from Hilary Loftus, who said, what a great panel. Thank you. Just what I needed to hear. Sheila Thelen is awesome and an amazing collaborator. So we hear from collaborators, Sheila's collaborator. Sheila, you're really making a difference. I can definitely see that. Okay. Nikhil, yes.
And
Yes.
you guys can see my screen.
Yes, now we can see
Amazing.
your screen.
So today, as I said, I will really be talking about the project that I've been working on in my PhD, where we are trying to restore upper limb motor function after stroke using implantable spinal cord stimulation. So stroke, as most of us will be aware of, is the leading cause of paralysis in the US, with about 800,000 new patients every year. And 50% of these stroke survivors are affected by permanent motor deficits of the arm and the hand. And there's very limited clinical therapy in the chronic phases of stroke. So after 6 months, there's very limited amounts of therapy which is currently available, and physical therapy which is traditionally used, is much less effective in the chronic phases. And it leads to a devastating effects on the quality of life of these patients and their loved ones. So when a healthy individual tries to move their limbs, the signals from the brain travels all the way from the motor cortex via spinal cord through the motor neurons to the muscles, allowing them to move. However, in case of stroke, because of the lesions in the corticospinal tract, which is the signal transmission for the signals from the brain to the muscles, there are lesions, and it doesn't allow these motor signals to be able to effectively reach to the muscles, leading to joint weaknesses, abnormal muscle coordination, loss in dexterity, which is very stereotypical behaviors in people with stroke. However, there are still these spinal circuits below the lesions which are completely intact, especially in the case of stroke and also in case of spinal cord injury, that can be harnessed, and these are completely capable of producing movements. These targets or these circuits could be activated using some sort of pulse generation or electrical stimulation. So in case of spinal cord stimulation, we are targeting these sensory neurons, which has direct and indirect projections to the motor neurons, which will, and using that, we can target these muscles. The benefits of this is because there is a presynaptic activation of these motor neurons, they tend to be fatigue resistant. So in case of functional electrical stimulation, when we are stimulating directly the muscles, that tend to cause a lot of muscle fatigue. So that's why this presynaptic way of activating these motor neurons is resistant to that. So we can turn on the stimulation for a much longer time. So using this idea, we had a clinical trial where we tested with 7 participants, where there's these leads that goes inside the epidural space. These are FDA-approved leads and linear leads that goes inside the spinal cord. And we connect an external stimulator to these leads. And these leads would stay into the spinal cord for 30 days, and then we would implant them and do a bunch of testing. And this, the leads basically looks like a spaghetti. These are very small, flexible, that goes inside the spinal cord. Once these leads are implanted, we need to be able to map within the spinal cord which contacts to activate. So one thing that we know is within the spinal cord, there is this rostrocaudal arrangement, rostral meaning towards the head, caudal meanings away from the head, within the spinal cord. So the more higher up towards the head you go, there's innervations of these motor neurons of more proximal muscles like the shoulder. And the lower you go, there's activation of these muscles from the hand, the arm, and the biceps. So we basically implant the leads in the cervical spinal cord region and then try to stimulate individually on these 16 electrodes. And what we see is when we stimulate on the upper or the rostral electrodes, there is activation of the shoulders. And as we move down, there's activation of the biceps, triceps, and wrist and hand. So now we have a set of electrodes targeting these specific muscles. So then we would continuously stimulate on these electrodes and ask the participants to do a bunch of different things. Here I'm showing one of the participants trying to eat a Chick-fil-A chicken nugget. So without stimulation, you will see the participants struggling a little bit to be able to maybe pick up the fork. And they have these more because of their motor impairments. We are currently not stimulating anything. And you would see that the participant is struggling to maybe pick up the Chick-fil-A, the chicken nugget. And what you will see at the moment, let's just see. Just to make sure we are not stimulating anything and this is their baseline activity, we see that the participant doesn't have strength in their shoulders to be able to eat by themselves. So they need assistance from their non-impaired arm to be able to eat this Chick-fil-A chicken nugget. Now we are stimulating on the spinal cord, targeting the shoulders, triceps, and the hand. And what we see that the participant is able to pick up the fork in a much better way. They are able to poke the chicken nugget in a much easier fashion. And then what you will see is now their shoulder has the strength to be able to eat this chicken nugget. And now she's happy. So what we are seeing is the participants are able to modulate all of these movements, and they are the one controlling their arms. And we, by the stimulation, is only enhancing the signals from the brain to be able to perform this, for them to be able to perform these movements. So yeah, it's as I said, it's a very big collaborative project between UPMC, the medical college, University of Pittsburgh, and Carnegie Mellon University. And the study is led by Doug Weber and Marco Papagrosso, who are professors working in these fields. And I'll take any other questions.
Yeah, yes, very impressive. How do you see the final product? Where are you heading with it?
It's a great question because Marco and Doug, so the paper that we worked on highlighting these clinical results, the postdoc from this study now actually has a startup, and he's the CEO of a startup called, his name is Mark Powell, and the name of the startup is Reach Neuro, where they are really, by looking at the clinical, like amazing clinical results, he's currently working on bringing these technologies to the actual population. And yeah, so it's amazing to be able to have all of these conversations with him as well, to see what are the requirements to be able to make these devices available. So yeah, like we go back and forth between all the research work that we are doing in the university, in the clinical trial, and all the work that he is working on in his startup to actually bring these work to the people.
Yeah, so you get to see both worlds, yes, and be in the connection. So, what is the difference that you observe between one and another world of
It
neurotechnologies?
goes very similar into the lines of what Courtnie mentioned before, where grad students like me are really trying to get as much as we can and push the boundaries of what can be done with these neurotechnologies. So today are these very basic continuous stimulation paradigm where you select these contacts onto the spinal cord stimulation leads, turn it on, and just leave it on all the time. And now the participants are able to perform these complicated movements. What I've been working on is trying to develop, exactly as I said, these closed loop stimulation paradigms to target specific muscles in space on the spinal cord stimulation at the correct time, and turning it on while they are performing specific tasks. Let's just say when they are performing elbow extension, we would target a specific contact. Where they are targeting elbow flexion, we are targeting a specific set of contacts. So these closed loop algorithms is what we are testing. There are other students who are looking at the mechanisms, so really like boiling down into how we are seeing these effects. So the mechanisms are done by Erin Sorensen. There are other students who are working on, let's just say, closed loop algorithms to be able to how to optimize these stimulation parameters. So we really are trying to push the boundaries in science and engineering in the university. Whereas on the other side, Mark has been really trying to talk with all the investors to be able to say that, hey, these clinical trials have amazing results. We now need the resources to be able to build these systems to be able to, for it to be able to work in real world. And you can imagine for industry standpoint, the minimal viable product that works effectively is what a startup would need. They don't want to complicate the things as we are doing while we are pushing the boundaries of the field itself. But if something works and if it's easy enough to implement, that is the solution that a company or a startup would prioritize over anything else.
Yeah, thank you so much for this inspiring presentation. And does this work inspire you? Do you already start getting some ideas? You know what you would like to do? Maybe in a startup domain, or just some project. Maybe even not going to a startup, but idea for something you would like personally to do.
Yeah, so I think one of the goals that I had with my PhD, coming from my undergrad back in India and not having these neural engineering or neuroscience background, was to be able to build depth and breadth at the same time. So I've had a chance to also work with patients with implantable BCIs with Jennifer Collinger at University of Pittsburgh. So there are patients with severe paralysis. They have implant in their motor cortex to be able to decode the signals directly from the brain and then control either a computer or a robotic arm, allowing them to be able to perform complicated tasks. And then in my PhD, I've also worked on these neuromodulation to be able to restore these movements or neurological conditions in the same population. So currently in my next, I've seen these systems to be able to build in the lab and directly implemented in the patient population and everything that goes in the middle. from them, of course, in a research settings. And as I mentioned before, I think in the next steps, I would like to combine all of this breadth of knowledge and then learn also on the next side, which is in a startup, to be able to effectively build these systems according to the industry standards and FDA standards, so that they are much more effective, not just effective, let's say consistent in the way they perform these therapies. So I think that would be the next step that I'm curious for.
Yes, amazing, amazing. And there is a question for you already, Nikhil, from Rachel Charles, and she is asking how much carryover is there into everyday function when the electrodes are removed, or is this the next phase of this study?
That's an amazing question that I didn't get to. So in this current study, we are really only testing the immediate effects of spinal cord stimulation, of how, when we turn on the stimulation, what are the effects on the motor properties themselves. However, the other aspects that we have noticed, which was really unexpected, is because we are doing the stimulation over the course of 30 days, what we have seen. So one of the things that we do is we do repeated experiments over the course of these 30 days. And what we have seen is that, and so the study design is, we have the participants come to our lab before the implantation to get their baseline. Let's just take an example of strength. So there's a level of force that they can generate without stimulation at the beginning of the implantation. During the 30 days, we do all of these tests again and again to be able to see what are the immediate effects of spinal cord stimulation. And we also do a bunch of clinical tests, one of the tests called Fugl-Meyer, to really see their ability to be able to perform these complicated movements, and the test of dexterity, let's just say. But what we have noticed, surprisingly, is over the course of 30 days of delivering stimulation and participant performing these movements, there were actually some carryover effects, which were completely unexpected in our cases, because that was not the goal for the study. But over the course of 30 days, for participants who have had paralysis for last 9 years, we are still seeing some residual effects. But these residual effects actually tend to fade away. So far, at least so far, what we have seen in these 7 participants is that they last for, let's just say, about a month, and then they start fading away. So what it basically is telling us that we need to explore further in the next phases of the study is to see if the stimulation really has to be delivered all the time for them to be able to see these effects or not. So the next phase of the study is these implants will be going in their spinal cord for the course of 90 days. And then we'll really trying to develop the clinical study to answer some of these questions.
Thank you so much, Nikhil. Thank you. And thank you for your question, Rachel. I would like now maybe to switch to Sheila, because there is also a question to Sheila. Yes, so Sheila, maybe you can tell us briefly what is your focus right now. And the question for you will be about, so it's from a LinkedIn user. We don't know who this user is, but the question is great. Hello, everyone. Thank you, dear Miss Milena, for all the amazing speakers. Dear Sheila, how do you keep track on the conditions of your trainees, especially those who not very healthy, who is not very healthy? I mean, do you rely on their own feedback, or use special hardware or software tools, or collect any examination results from third parties, doctors, medical assistants, etc.? So I know that Sheila is collecting the data, and I will send you a link for everyone to listen to her podcast. She really goes into all details about what she does, provides examples, but let's hear from Sheila now, at least briefly. Yes, Sheila, please.
So we partnered, good old partners. We had a previous bounce mat company that we used for 4 years, but our new bounce mat company, we used a company called Bounce Tracking Systems, FDA approved, national standards, tons of data that comes out of it. That's also very easy for clients to understand. So we use, they have a fall prevention test to see how close and, how wobbly you are in fall prevention risk. But they also have something called a modified CAT SIB that comes out of the PT world. And really, it's 20-second size open on a firm surface, 20-second size closed on a firm surface. Then we add the foam, that blue cushy foam stuff, for 20-second size open, 20-second size closed on the foam. So we pre-test everyone. And then, of course, we gently spin. We use our intervention, which is spinning. And then we post-test with people. And of course, that's where we collect the majority of our data. We have had shocking data changes on our clients, and we just have thousands of pieces of these things. They're just everywhere, and it is really fun to follow. You know, they moved 16 centimeters in the pre-test, and in the post-test, they only moved 14 centimeters. So moving from the 55th percentile, they jumped up to the 72nd percentile. So, like, we just have miles of this data. And the other piece that this data also shows too is their ellipses of how they moved. Are they big and fat? Are they moving a lot of north, south, east, west? Or are they just kind of bringing that all into a north, south region? So we have so much data from this. But we also teamed up with Neurocatch. All these companies have neuro names. So you got to get your mouth ready to talk. And so Neurocatch, we did pre and post brain scans, and it's an EEG that tracks electrical signal. And I'm going to take 1 second to talk about it was shocking data that came out of Neurocatch. I tear up a lot. One of our long-term, really concussed guys that we work with, after 6 months of working with us, tested normal on his brain scan. And I'm just going to cry about that because he really came a long ways. The other 3 clients we worked with, I just have one of them was a stroke patient with concussions, and pre and post spinning, she only improved by 100%. Okay, only. My early onset Alzheimer's lady improved by 400%. Even I'm blown away by this data. And the really interesting one was the gentleman with special needs. His left hemisphere was inactive in the pre-test, and in the post-test from spinning, the left hemisphere became active and talked to the right hemisphere. So these are the things that we're really excited about. But when I always go back to vestibular, and we want to talk about the big 4 things, obviously, you know, we're showing huge improvements in balance. Like that's easy enough to do. To the point I'm almost bored with that because I can show it so easily and it always happens. It's almost boring to me now. But balance, you know, tracking through balance tracking systems. In addition, cognitive tracking through Neurocatch. Spatial is a little harder to show, but people really come back with, my peripherals have opened up. Have you changed the lighting in this room? Because their vision has opened up. So they notice the lighting more. But the other big thing of sleep, West Side Barbell using Oura rings and Apple watches showed a 73% improvement in sleep in their elite athletes. So that goes back to recovery. And of course, when we also talk about sleep, that's everything. Hello, being a human, you know, your brain cleans itself. And those are the really nice things. I do have one thought, and this is where I'm a big believer in pre and post testing. And everything that we've pre and post tested on, whether it was neck care, which is kind of like a moving laser that you follow with your head and neck, pre and post testing with that, pre and post testing with NeuroTracker with the moving ball games and Dynavision and their Zeus system, which is a big smack board. Everything that we've pre and post tested with, we've seen changes in their scores. And that's the exciting part of vestibular training. I think we all assume that elite athletes understand their bodies. And I'm going to take a second to tell you that's not true. And especially my military guys, and even I'm going to specifically say my Navy SEALs that I work with, they've been taught to disconnect from their bodies. You know, your knee hurts, your back hurts, you haven't slept, your elbow hurts, you've been shot. Okay, well, you need to ignore that and keep going. And so they really don't always feel their bodies the way we assume they would, that you think they'd feel those changes, and they don't always. So pre and post testing really, really is key. When you talk about how long do the results last, for us, the results last about 3 days. So you spin with me, the results last about 3 days. But most of my clients work with me twice a week, on a Tuesday and a Friday. Yet and I have a batch that work with me once a week, and they're plenty happy with their results. But my athletes are 7 days a week, and my kids that trained in the Ukraine, that left the Ukraine, were Russian trained and came and trained here with me here in Minneapolis. They told me they were doing vestibular training 3 times a day in Russia. So I do a whole thing on, I'm not the only one that's figured out vestibular. Obviously, the Russian athletic teams have figured it out too. Go Russia 3 times a day. They're really working those kids. So with that, but the interesting part is, how long does it really stick? And the answer is, at the 6 to 8 week mark, it really sticks to the point I can't get you dizzy anymore. And you've really adapted to the machinery. And to the point when I offer people to cut back, I'm like, okay, 6 to 8 weeks, you're doing great. Let's just cut this down by half. Almost all my clients are like, no, I'm good. I'm happy. I'll see you twice a week. They don't cut back when they're given the opportunity to, because they enjoy it and they are feeling the differences. So it'd be really fun to track your work at that 6 to 8 week mark. And to be honest, that's also where the PTs and OTs talk about their success, whether it's a knee injury or a back injury, that 6 to 8 week window is the magic for humans. Don't we all wish we could jog once and lose 100 pounds? That's just not how humans work. I go to one class and I pass it. No, that's not how humans work. There's an education phase and there's a human learning and a body performance there's a reason why classes run 8 to 10 weeks, because that's where the learning gets done. So going back to it takes time, it's not a once and done. I get the question all the time too. Can I do it once and never do it again? And I'm like, yeah, I read one book, and I'm done, like that's just not how humans work. And I think it's always the delusion within us as a population that we can instantly do something. But when you do spin with me, the first time you do it, you feel it. It's that spidey sense. It's an alertness. It's kind of like I really got my act together, which is just a different feeling. So beyond feeling, we really can track scientifically. And I do have to take a second on, I feel like in the old woo-woo world, like, oh, this seems a little woo-woo. With science now, we really can pre and post test stuff on lots of topics, even some of the older ancient concepts, and see results. The 5 Tibetan spinning theories. It's a 3,000-year-old concept that we really can pre and post test now and see the changes.
Yeah, thank you so much, Sheila. Thank you. Amazing. And I refer everyone to listen to the podcast with Sheila. It is very impressive. You all get so many details. So thank you, Sheila. And we don't have much time left. Courtnie, can you share what are you working on? What's going with you? And then maybe each of us can share some opportunities that that are coming up in the field, and any events our attendees might also consider. Thank you. Mm-hmm.
So a big part of what I'm working on right now, so I'm in software. So part of the pivot in my graduate years, I worked with the patients, with the implanted devices, right? Kind of building these bidirectional interfaces, sometimes literally in the room with the patient. I'm kind of abstracted that knowledge, and I'm working really on the software interface right now. So I've assembled a pretty kick-ass and growing team of builders, and we are working on posing the problem in a very solvable way. And I know that sounds simple. We're tying in, again, this kind of like multimodal AI module to a central, we'll say, decision architecture. We're calling it our Carla, our context aware AI engine, and learning or iterating on ourselves. What are what are the salient bits of information in our latent environment? How do we reliably capture those? And then how do we inform an agent to make decisions on behalf of the user? And that interaction space is very, it's very artistic in the sense that it is unexpected sometimes. You'll build something that you worked through in your mind, and then you'll see it and you'll interact with your own creation, and you'll immediately go, okay, I had no idea I was going to feel this way about it. So now we need to tweak that. And we have, placeholders while pieces come together, and there's this unfurling process that's happening in the software then that we're tackling right now. And I'm only keeping it hand wavy because I think in a couple minutes, maybe the low level details would be inappropriate. And I'm still learning that balance as a company, and what you say and what you don't. But I would say working on human AI interface is a big part of what the company is doing. It's a swell becoming a wave that I think a lot of companies are going to catch and ride to shore. I think the next generation of the way that humans interact with their technology, I keep making the analogy that we're not building sci-fi anymore. We're building fantasy, right? I think the future is Harry Potter. The future is magic as much as we've grown up thinking about it. This non-local interaction with objects, the seemingly intuitive but non-intuitive way that wizards relay with their environment. I think it's fun. I look forward, Milena, to the next podcast where you're able to have the sci-fi author on, because one of the beautiful things that artists tend to do is they project, right? Build a narrative around the, like, what if this, right? What if gender was something you could choose, and we get Left Hand of Darkness, right? Like, it's these fascinating what if concepts. And I do think the world of what if magic has built some really inspiring alternative realities that I see us with this AI partnership and human AI collaboration making real. And that would be my
Yes, thank you so
summary.
much. And that's such a great insight. And, not sci-fi, but fantasy, yes, and magic and Harry Potter. That's a beautiful way to demonstrate where we're heading. I'm so sad that our sci-fi author wasn't able to join. She joined for a moment, but she had a storm. So even she was able to join, her camera and her microphone didn't work. In any case, we will wait for her, hopefully for the next time, and maybe we can have this discussion. And actually, I started as my just pet project, my hobby project, a podcast on magical professions, where I interview people actually from very, very strange, sometimes disciplines, but it's again to see that perspective of where can we go. Like, some people are talking about telepathy, but we're somewhere there. Yes, if we can exchange our information between each other, that is a way of to for telepathy to really manifest itself. Yes, but in just scientific type of way. And this is how I met Dante Terese, who writes about sci-fi and actually in military applications. Yes, how we can use those various sci-fi technologies and whatnot. So, and I also want to mention that Courtnie is actually former military. Yes, Courtnie. Yes, Courtnie was flying helicopters. Can't imagine. I'm so impressed by people I've met. That's absolutely amazing. Maybe you and Sheila can have interesting conversations. Yes,
Mhm.
so about that. So thank you very much, Courtney. And we're almost at the end of our podcast. Maybe we can all share something that our listeners can and viewers can look into any opportunities, workshops, seminars, upcoming conferences, maybe job opportunities, internships that you are aware of in the field, or maybe even projects, areas of applications of neurotechnologies where people can try and find themselves, yes, creating the devices, creating solutions. Yeah. Mm-hmm. Who would like to start? Yes.
I've got two, so I'll jump in real quick.
Yes.
So,
Yeah.
Neuralink was the first company that I realized had open job calls, meaning, hey, if you think there's something that we should hire for, go ahead and submit it to us.
Mm-hmm.
I think I've seen that now in more places. I don't know if it's like I'm buying a red car,
Mm-hmm.
and so I see red cars everywhere.
Mm-hmm.
But if people aren't aware of that, I think that's such a brilliant, maybe it's kind of like an entrepreneurship thing. If there's a technology that you're excited about and you think they should be doing blank with it, if you have a really good case, make the job, call it something and submit that. I think that'll be an increasingly cool way that one, people find work that they really care about, and two, companies find that expansive vision. And then also in the startup world, major accelerators, so Y Combinator, for example, they have a list of jobs that their companies typically these accelerators will bring on like a founder co-founder team, like a teeny tiny teams, and under the course of the accelerator they tend to need to expand. Those job pages are pretty fascinating. And the startup world is high risk, right? We talked about startups tend to fail, founders don't tend to long term. And so getting in with teams that are taking those risks and moving very quickly is something that I think is an exciting option that maybe people don't know exists. Great option if you have a little bit of runway near the end of your PhD, just saying, sometimes postdoc, but I think PhD is one of those magical places, especially if, for example, you've built this incredible tool set and you can do so many things across such a breadth. The startup world, you can found your own, but joining as that employee one or that co-founder is a brilliant option.
Thank you so much for mentioning that, Courtney. Those are very important things to consider. I agree. I also want to let our listeners know that we have a wonderful podcast with Courtney. Yes, and you can hear all about her career, how she went from physics, yes, military, flying helicopters, into research with the epilepsy patients, people with epilepsy, and trying to create those sensations for them, bidirectional BCS, and now she already has her own startup. So amazing. Please attend. And about those opportunities that we're mentioning right now, I will send a newsletter. I already sent the one based on the previous meeting, our roundtable, and I will send it in a newsletter. So if you want to receive this gist of what we talked about, please subscribe, and the link is again in our chat. So thank you very much, Courtney. Okay, Nikhil, Sheila, who would like to speak next? Mhm. Mention opportunities. Yeah. Nikhil, I cannot hear you for some reason. You might be muted. Is that possible? No. What's happening? Because I cannot hear you. Yes, can you try speaking again, Nikhil? No, we don't hear you. Ah, okay. Let's hear from Sheila while Nikhil, you will try to figure it out. Uh-huh. Yes, Sheila.
Yeah, look at all that technology. Oh no. Sorry.
It happens.
It happens. So I talk about jobs all the time. Like we talk about our taco trucks, our portable gear. We talk about trainers, chiropractors, all these people that are putting our gear in and adding it. I'm possibly the most excited about putting in multiple neuro gear quite affordably in schools
Right.
that ultimately, a para could run. Not having to go back to college for 4 more years to learn how to run all this gear to apply to the children today. Not years away from now, we could do it right now. So, of course, I think my gear is great, but I think when you put it in combo with 5, 6, 7, 8, 10 other pieces of product, it's unbelievable in all the ways that we can help kids. So kids are the fun projects that we do. We love a weird project, but kids are weird, so it's super fun. And I feel like there's so many jobs that could be created in this. I feel like we could also have so many. There's so many sensory rooms out there right now, but to add neuro more to the sensory, I think you could easily franchise that out. Call me, we can help you. I feel like there's some really cool franchise opportunities and licensing and things that you could really own your own business that could help change the lives of children and communities. And we always talk about the person that's injured, but what about their whole family? And so really the whole family can get assistance in helping that one person. So I think this is an industry that is so exciting, but something you can really care about. That obviously everyone that's speaking today and that works in the industries are really important, and I really am excited not just to be a part of it, but to of course work with all these other people that are really changing the world and not sounding crazy for saying that. Like, what's the goal of your company? Change the world. And we're all going to do it. And I think that's the goals and the level of obsession that you see within this whole event. Thank you so much. But like everyone here is going to change the world. And I encourage people to come and join us.
Thank you. Thank you so much, Sheila. Beautiful. Nikhil, how is your...
Can you guys hear me?
Yes, we can
Amazing.
hear you now. Yes.
I literally didn't fix anything, but let's see. So I basically wanted to give a little bit of perspective, maybe on the initial side, just because there might be a lot of students, maybe not even from the United States or somewhere outside, who might not have access to this field itself. So one thing that I really would recommend is whenever you see like any sort of podcasts like these, like the science communicators, of course, like Milena, yourself, and there's many more who exist both on platforms like YouTube or on LinkedIn. One of them, for example, the way I also learned about this field is someone called Jojo Platt. Her name, she's incredible. She communicates a lot about the field itself. So joining and connecting and following these people is really easy way to be able to be more informed about what's going on in the field itself. And then at the same time, reaching out to these folks that maybe are mentioned in these podcasts to be able to, again, know what's going on in the field, what might be interesting to you, and then harnessing everything that exists online to be able to learn, again, the basics of the concept, to maybe drive these small projects that you work on in your undergrad, to maybe able to fit in these really small domains that helps you building these basic skills that then you can harness and portray that, say, hey, we're using all of these very limited resources because I'm really interested in this field. You can build these things, and then that will allow anyone who might have some resources, maybe in the universities, on startups, to actually give you a chance so that you can actually learn and apply and make these things happen.
Thank you so much, Nikhil. Thank you, everyone. I invite everyone also to join us in a month on our next event of our next Neurocareers Nights of the Neurocareers Roundtable. And if you're interested to be a panelist, please let me know. Yes, because that's what we're trying to do, to really build the community and provide everyone an opportunity to speak about what's going on, what trends do you see, what are the challenges, what are your recommendations. So please don't hesitate to contact, and we're looking actually for people also in their beginning, in their early career development. Yes, like Nikhil, and the master students, and even bachelor students. That's okay. Yes, and maybe you are a high schooler who is interested in the field. Oh, that's wonderful. Yes, and of course, already seasoned professionals. So let's all come together and talk. And if you're interested in your career development, I offer free consultations, free Neurocareers consultations at our Institute of Neuro Approaches. So the link is here. Please contact me at any time point. And also, I would appreciate if you support our YouTube channel by subscribing and commenting. We have so much wealth of information there. So thank you again, all the panelists. You are absolutely amazing. You are changing the world. I wish you all the best and hope to see you in our next event. So thank you.
Thank you for having us.